In this and the next few videos, I want to explain or prove the formula for n choose r. Now, in this first example, I'm going to explain the formula, why the formula works for 4 choose 2. And there's going to be times in this explanation when you're just like thinking to yourself, why don't you just count them? There's only 6 of them there, or there's only 12 of them there. And honestly, in my, if I was just trying to get to the answer, then that's what I would do. I would just count them. But I'm trying to illustrate something in general here, but I'm going to give you a specific example, and through a few examples in this and the next couple of videos, I'll show you why the formula works. This also is gone over in the Xi book, so I'm going to add to what is there. All right, so the first thing to notice here is that over here I have listed all of the 2 permutations of length 2, where the symbols are taken from that set. And so that's all of those 2 permutations. You can see that there are actually 12 of those there. Okay. Over here I have all of the 2 subsets, all of the 2 element subsets of the set A, B, C, D. Now I would like to because all of these over here are the 2 permutations, I'm going to call this set the set P. And because this is all of the 2 element subsets, I'm going to call this set the set S. Okay, P for permutations, S for subsets. All right, now you can imagine a function f from the set P to the set S. Right, and we'll define this function f from P to S. F. So what f is going to do is it's going to take a 2 permutation, and send it over to a 2 subset. And so let's define a general permutation. I'll say xy. So xy lives in P, right? So xy lives in P. Right, so what is x, what is y? X is one of these first things, like so x could be A for that thing, right? And then y would be B, or x could be A, and then y would be C. So this xy here, it is a general, it encapsulates all of the things in P. Now, where do we want to send xy to? Right, we want to send xy to a 2 element subset. So remember here, order matters because this thing's in P, and permutations order matters. And we're going to send it over to a subset. So we're going to say f of xy equals the set xy. So basically what we do is we take something over here, like let's say so f of AB, so here's a specific thing in P, and we just put a comma between A and B and put brackets around them. Right, and so you can see that f of AB is equal to the same as f of BA, because this would go to BA, and these are equal, right? These are equal because sets order doesn't matter. Okay, so now using our function, AB gets sent over, the permutation AB gets sent over to the set containing A and B, BA gets sent over to the same thing. AC goes to that, CA goes to that. AD goes there, there goes there. There goes there, there goes there. That goes there, that goes there, that goes there, and that goes there. All right, now you might think of this as, and this is exactly a 2-to-1 map. So if you studied, remember from studying 10.2, section 10.2, which we studied back with functions because it was about functions, this is a 2-to-1 map. Okay, and so now think about so the first thing we can see is that the cardinality of, let's make this an S here. The cardinality of S, the number of two-element subsets, in this case 6, is equal to, because it's a 2-to-1 map, and even if you don't remember the 2-to-1 map, then you can just see here by looking at the number of connections, the number of things in S is 1/2 of the number of things in P. And try to see why this is, but beyond just saying, okay, well, sure, 6, which is the number of things here, there's 6 things, right, is 1/2 of the number of things here. But there's more to this than just saying, okay, 6 is 1/2 of 12. It's really because each one of the things here, right, each one of the things in S has 2 things in P coming over to it. Okay, now another way we could write that, let's just leave it like that. Let's just say that's 1/2 cardinality of P. Okay, now remember that the cardinality of P, right, this is the number of permutations of length 2 where the symbols are chosen from an alphabet with 4 symbols in it, A, B, C, D. Remember there's a formula for that. Okay, so this is what we would say is P for 2, which remember there's a formula for this. This is 4 factorial over 4 minus 2 factorial. Okay, so the cardinality of P is 4 factorial over 4 minus 2 factorial. Okay, so that tells us that the cardinality of S, whatever it is, right, this is equal to 1/2 times 4 factorial over 4 minus 2 factorial, which is equal to 4 factorial 2 times 4 minus 2 factorial. Right, that's the cardinality of S. That's how many things are in S. The number of things that are in S is the number of things in P. The number of things in P is the number of permutations of length 2 where you have 4 symbols to choose from. There's a formula for that. It's exactly that, 4 factorial over 4 minus 2 factorial. So the cardinality of S is 4 factorial over 2 times 4 minus 2 factorial. Right, because the cardinality of S, like we said, is 1/2 of whatever the cardinality of P is. And the cardinality of P is that. So that would mean that the cardinality of S is 1/2 of that, which is what we have here. Right, 1/2 times that, doing the math, 1 times 4 factorial is 4 factorial, 2 times 4 minus 2 factorial is 2 times. Yeah. Okay. All right. So So now, and this is kind of a silly thing to do, right? I mean, you can see that 2 factorial is 2 times 1, otherwise known as 2. So you could write this as 2 factorial. But there's a real meaning to why this is 2 factorial. And the real meaning is that when you look at any one of these things over here in S, let's say AD, and you go backwards and you say, what are the things in P that came over to AD? Right? How many different ways can you write out a permutation that gets mapped over to AD? It's 2 factorial ways, because there's over here so you think of it as like there's 2 positions. 2 positions. You could put AD. Okay, that's that. Or you could put dA, that's that. That's 2 factorial. So that's why it's 2 factorial there. Okay, so then we've established that the cardinality of S is equal to that. Okay, now what is the cardinality of S? The cardinality of S is the number of 2-element subsets of a set with 4 elements. We've already established before that that is really, we use the notation 4 choose 2 for that. So here you see that 4 choose 2 is equal to 4 factorial over 2 factorial times 4 minus 2 factorial. And the thing that I want you to get from this, the thing I want you to get more than anything from this is that, let's see, cardinality of S, that's 4 choose 2. Well, that's just 1/2 of P. Right? It's 1/2 of the number of elements in P, right? Because we have a 2-to-1 map. And now what is the cardinality of P? Well, that's this formula. And so therefore we have that.